everybody, it's Mrs. Hofferberth, and we're going to talk about multiplying and dividing with significant figures. So for multiplying and dividing, we have a single rule, and that is that we're going to round the calculated value to the smallest number of significant figures in any of our measurements. So let's look at a couple of examples. So for this first one, when I multiply these two numbers together, I get 7.300 on my calculator. And when I get 7.300, since I multiplied my units are going to become inches squared. To decide where I should write my value, I am going to want to count the significant figures in each of my measurements. So this one on the left here has 3 significant figures, and 2.0 has 2 significant figures. The last 0 is significant because it's trailing and there's a decimal point. Well, between 3 and 2, 2 is the smaller number, so I only want 2 significant figures in my final answer. That means starting from the first non-zero number on the left, I'm going to count over 2 spaces. This is the last decimal place that I'm going to include in my answer, and I'll have to round to that value. Well, in this case, 7.300, that's just 7.3 because it's right at that point, so I don't have to do anything fancy. So my final answer is 7.3 inches squared. The division example down below, we're going to play the same game. We'll put it in the calculator. And when I put this math problem, this 46.84 divided by 4.1, I get 11.4244. According to my calculator, units, I've got grams over divided by cubic centimeters. Since those aren't the same, I will just write them in their appropriate numerator and denominator location. And then I'll look at my rounding. Okay, so 46.84, this has 4 significant figures. All of those digits are significant because they're not 0. 4.1 only has 2 significant figures. So 4 and 2, 2 is smaller. So starting at the first non-zero number on the left, I'm going to count over 2 spots. Okay, this is the part I need to keep. I need to round this to the ones place. So I will look at the digit after the ones place. In the 10th place, I have a 4. That means that this number is between 11 and 12, and being 11.4244, it's closer to 11. And so this is going to be 11 grams per cubic centimeter for my final answer once I've rounded to the appropriate number of significant figures. Let's do 2 more. Okay, so I'm going to multiply 16 by 3.64 by 2.00 on my trusty calculator right here. And I get for an answer 108.8. Unit-wise, before we go any further, I've got centimeters times centimeters times centimeters. Since those are all the same, this is centimeters cubed. Okay, sig fig time. Count the number of significant figures in each of your measurements that you're multiplying in this case. So I've got 2 sig figs. I've got 3 significant figures. Those are all non-zero numbers, so they're all significant. 2.00, that has 4. Those zeros are trailing. They're after a non-zero number, and there's a decimal point. Well, now I just have to look at which has the least number of sig figs, 2. So I need to round this value to 2 significant digits. So I start with the first non-zero number, in this case the hundreds place, and if I'm going to go 2 digits over, I'm going to get to the tens place and have to stop. So I'm going to round to the tens place. I look at the number after it, it's an 8. Well, that's going to be closer to 110 than it is to 100. So this is going to be 110 cubic centimeters. I want to point out that this only has two significant figures because this 0 is not significant. Not significant. And that's because it's a trailing 0, but there's no decimal point in the number. So that does only have 2 sig figs. Final example, another division problem. 75.6 divided by 17.540. Break out the calculator. Okay, my calculator tells me that this is 4.31015, but I don't actually know the measurement that well. Let's do units and then sig figs. My units here are going to be grams over milliliters, significant figure-wise. We have 3 sig figs in the numerator, all non-zero numbers. And we have 1, 2, 3, 4, 5 sig figs in the denominator. That final 0 is significant because it is at the end. It's a trailing 0 and there's a decimal point. Well, 3 versus 5, 3 is the smaller number. I need to round my answer to 3 significant figures. So again, I'm going to start with my first non-zero number and count over 3 decimal places. And then I'm going to round. Well, this rounds to 4.31 grams per milliliter because what remains is less than halfway to the next number, less than halfway to 4.32. And so when you're doing significant figures with multiplication and division, and you'll use this so much this year, count how many significant figures you have in your measurements, find the one that's the smallest, and then round that same number of significant figures in your final answer. Don't worry, we'll do lots of practice.